Hello everyone, welcome back to our channel. So dynamics is very important part of the mechanics. If you want to score the good marks or if you confidently pass this subject, then solving the problems related to the dynamics are very important. To solve this problem, we can target few problems related to the dynamics. So out of that, one topic is variable acceleration. So in this video, we'll understand how we can solve variable acceleration problems. So for variable acceleration problem, we should have little bit knowledge of differentiation and the integration. If you have that knowledge, you can solve these problems very easily. So watch this video till the end to understand how we can solve this type of problem and score good marks in the mechanics. So we'll start with the question. The velocity of a particle traveling in a straight line is given by v is equal to 60 minus 3t square meter per second, where t is in second. If s is equal to 0 when t is equal to 0, determine the particle deceleration and position when t is equal to 3 seconds. How far has the particle traveled during the 3-second time interval and what is the average speed? So here, first we should understand what is the given data. So now here first value is given, that is v is equal to 60 minus 3t square. So we can use that value. So first we'll write the given equation. V is equal to 60 minus 3t square. That is s is equal to 0 at t is equal to 0. This is the given data. So with this given data, we'll try to analyze this question. Now the equation for the velocity is given. So from the velocity, if you want the acceleration, what we can do, we can differentiate this equation. And from velocity, if you want displacement, so we need to integrate this equation. This way we have to proceed. Okay. The basic sequence is displacement to the velocity to the acceleration. So for this sequence, differentiation is required. When we move on from acceleration to the velocity to the displacement, then integration is expected. So just you have to remember this sequence, what is given and what is required. So if you know what is given, now in this case, the velocity is given. So from velocity, I want displacement and the acceleration. So for that, I should do differentiation as well as integration. So once you understand this, we can proceed. So to get the acceleration from the velocity, we should start with differentiating above equation with respect to time. So differentiating above equation, we get here dv by dt, it is equal to, what is differentiation of 60? 6 is constant, you can take it outside. Differentiation of t is 1. Minus 3 is a constant, take it out. Differentiation of t square is 2 into t. This way we can write. So here dv by dt is nothing but acceleration. So acceleration is equal to 6 minus 3 into 2 is 6 t. So this way we get this equation, acceleration is equal to 6 minus 60. Unit of this acceleration is meter per second square. Getting? Now from this velocity equation, we'll try to find out 60 minus 3t square. We'll find out displacement. To get the displacement, we should integrate this equation. Now what is v? V is equal to dx by dt. So we'll put it there. So dx by dt, it is equal to 60 minus 3t square. Now this dx is equal to 60 minus 3t square into dt. Right? Now taking integration on both the sides, dx is equal to integration of 60 minus 3t square dt. So in this way we can write this equation. Then this dx, integration of 1 dx is x. So we'll write it here x. It is equal to integration of 60 dt minus, we'll take 3 common, integration of t square dt. So this x is equal to now integration of 60. So integration of 6 is 6 constant. Integration of t is t square by 2. Remember, integration of x raised to n, it is equal to x raised to n plus 1 divided by n plus 1, where n is the power of that term. So here the power of t is 1. So t plus 1 means 2 divided by 1 plus 1, that is 2, minus 3 into t, power is 2. So 2 plus 1. So t raised to 3 divided by 2 plus 1, that is 3, plus constant of integration. So here x is equal to 6 by 2 becomes 3 t square minus the 3 get cancelled, t cube plus constant, right? So here we get this equation, x is equal to 3t square minus t cube plus c. Now we'll find out the value of c. For the some boundary conditions will be given, like s is equal to 0 at t is equal to 0. We'll use that equation. S means x. So we'll write x is equal to 0 at t is equal to 0. Now by putting these values here, x is 0, t is 0 means this is 0, minus 0 plus c. So here the value of c becomes 0. So you can put this value in the previous equation. So previous equation is this equation. So put the value here. So here x is equal to 3 t cube minus t cube and c is equal to 0. So this is our next equation for the value of x. Right? By doing this simple integration and differentiation, we can find these values. So I will write equation here. So here the value of x is equal to 3t square minus t cube. So remember, this is not t cube, this is 3t square. Okay, so this is the value of x. Unit is meter. This way we have calculated the values of equations for acceleration and displacement. Then next, what is asked? Find the position when t is equal to 3 seconds. Now we'll find out the position when t is equal to 3 seconds. So here at t is equal to 3 seconds, we can put the values here. So acceleration at t is equal to 3 seconds becomes 6 minus 6 into 3. So it is 6 minus 18, that is minus 12 meter per second square. So displacement at t is equal to 3 seconds becomes 3 into 3 square minus 3 cube. So this is 27 minus 27. So this is 0 meter. T is equal to 3 second, displacement becomes 0 meter. This way we have calculated the values of displacement and acceleration at t is equal to 3 seconds. So we will find out the next term, that is how far has the particle traveled during the 3 seconds. How far? They have asked about the distance, not the displacement. And what is the average speed? Right? So particle has started from this position at t is equal to 0. It has moved up to t is equal to 3 seconds. So you have to calculate the distance traveled by that particle. So before that, we should calculate how much time it has made its velocity 0. So for that, we'll consider v is equal to 0. I'll write here v is equal to 0. So here we get the equation as v is equal to 60 minus 3t square. So I'll put v is equal to 0 here. So this equation 60 minus 3t square. So from this equation we can take t common. So this becomes 6 minus 3t. So we'll find out the factor for this. So here t is equal to 0 and next equation is 6 minus 3t. It is equal to 0. So 6 is equal to 3t. So t is equal to 2 seconds. So when t is equal to 0 and at t is equal to 2, its velocity becomes 0. So it has changed its velocity, or its velocity has become zero at these two stages. So we'll try to find out here. So this is our particle at t is equal to 0. Then it has moved to t is equal to 1 second. Then after t is equal to 2 second, and then it is again, I think, come back at t is equal to 3 seconds, because its displacement becomes 0 at t is equal to 3 seconds, that we have already calculated, right? So we'll try to find the distance covered by this particle. So at t is equal to 0, velocity becomes 0. At t is equal to 2 seconds, velocity again becomes equal to 0, and it changes its direction. Now to calculate the distance, we can use the equation x is equal to, the equation was x is equal to, equation, we'll put the values here. So at t is equal to 0, x becomes 0, putting t is equal to 0. At t is equal to 1 second, x is equal to 3 into 1 square minus 1 cube. So it is 3 minus 1, that is 2 meter. At t is equal to 2 seconds, this equation becomes 3 into 2 square minus 2 cube. So it is 12 minus 8. So this is equal to 4 meter. So at t is equal to 2 seconds, its displacement is 4 meter. Means it has traveled a distance from here to here, that is 4 meter. This is the origin, and this is t is equal to 2 seconds. But at t is equal to 3 seconds, we are getting x is equal to 3 into 3 square minus 3 cube, that is 0. 27 minus 27, 0. So again, particle at t is equal to 3 seconds, it come back to this position. At t is equal to 3 seconds, it moves from this point to the original point. So this way, it has traveled from first position to the second position, that is, it is covered. Total distance traveled is equal to 4, plus again return to the original position, that is 4. So it is equal to 8 meter. So this is the total distance traveled by the particle, and the average speed can be calculated using the formula speed is equal to distance traveled divided by time. So total distance divided by time, or average time, total time. So what is total time here? 3 seconds. Total distance covered is 8 meter. So it is equal to 2.67 meter per second. This way we can find out the average speed, total distance traveled by the particle, and the required values. If the equation of displacement is given, from that you require velocity and acceleration, then we should differentiate the given equation. If the equation of acceleration is given, from that you require velocity and displacement, you should integrate the equation. If the equation of velocity is given, from velocity, if you want the acceleration, you should differentiate, or from velocity, if you want the displacement, you can integrate the equation. So by knowing these four factors, we can easily solve any kind of equation. If you find this video helpful, you can like this video, share with this your friends, and you can subscribe to our channel. Thank you very much for watching this video.